So, good afternoon, students. We'll just wait for another 2-3 minutes and then we will start. We will be doing solutions. So, please get your notebook, textbook if you want, so that you have some reference. Okay, so good afternoon, students. So please get your explain examples 5 and 6. Okay, in our chemistry homework and chemistry homework for NEET are the same. Sir, is our chemistry homework and chemistry homework? What is this? Is our chemistry homework and chemistry homework for NEET are the same? I didn't understand the question. You're asking me if the NEET students and the JEE students are writing the same homework. Yes, I'm giving papers, so I'm giving the same papers to both. They are both complicated papers. I'm not insisting on the NEET students to write, but I'm insisting on the JEE students to do the work. Yeah, screen has not yet been shared. I will be sharing the screen in a minute. Yes. So started my sharing screen. In another minute it will share. So done. Screen has been shared. Why is it more complicated for JEE? Obviously, JEE students, the exam is more complicated, so it is more complicated. In your JEE exam, you have 75 questions per 3 hours. In the NEET exam, they have 180 questions in 3 hours. So there will be a difference now, why, between this and this. Yes, NEET homework also you guys should write. There is no punishment for doing work. Okay, so don't ask whether you should do, you should do. Okay, here is a question. So let us begin with this question. The question is, calculate the molality and molarity of a Ki solution, potassium iodide solution, with 20% mass on mass in water. Okay, 20% mass on mass in water So yeah, so this is it. The density of the solution is given to you as 1202 gram per ml. Now you may be wondering what is the molar mass of Ki. So I can help you with the molar mass of Ki. So let me just check. Is 166. Molar mass of Ki is equal to 166. Okay, so calculate the molality and molarity of a Ki solution. So I will try to help you out. Okay, so first let us understand this is a 20% mass by mass in water. So if it is 20 mass on mass in water, can I say that in 100 grams of solution, in 100 grams of solution, there is 20 grams of Ki? Yeah, in 100 grams of solution, there is 20 grams of Ki. Yes, then there is 80 grams of water, 80 grams of water and 20 grams of Ki in 100 grams of the solution. So this much details I have. Then let me look at this. So what is molality? Molality is basically the number of moles in 1000 grams of the solvent, right? So molality is number of moles of solute in 1000 grams of solvent, right? So in 80 grams I have 20 grams. So can I say in 80 grams I have 20 divided by 166 moles? So in 1 gram I'll have 20 divided by 166 into 80 moles. In 1000 grams I'll have so many moles. So this is the molality of the solution. This is the molality of the solution. So let's try to calculate this quickly. So this 2 goes, this 2 goes, this 2 will become here 4. This 4 will become here 250. So the answer is 250 by 166. So 250 by 166 will approximately be 1.5 molar. So it will be 1.5 molar solution. Do we understand this? Yeah, so we found out the molality. Molality of a solution is defined as the number of moles of the solute per 1000 grams of solvent, per 1000 grams of the solvent. So in 80 grams of solvent I have 20 grams of Ki. So in 80 grams I have 20 divided by 166 moles. So in 1 gram I have so many moles. So in 1000 grams I have so many moles. So that is the calculation that I have done and I have found out. Yes, please work it out and see, let me know. So this week will we do test in organic or solutions? We will do a test in solutions, concentration of solutions, and whatever I teach till Thursday. Okay, so if this part is understood, we will move on. Okay, so if this is understood, yeah. Inorganic, we will be doing physical chemistry this week test. I've already clarified. Please explain example 5 and 6. Examples 5 and 6. I have not yet reached there. When I reach there, I'll explain. Example 5 and 6. Example 4. Example 5, I won't be doing it today. Next class only. No. It will take us long time to reach there. Okay. So this is how you find out the molality. Now we want to answer the molarity of the solution. So let's go to the next one. So this density information is what will help us. So density is 1.202 grams per milliliters. So can I say that in 1000 ml or 1 liter of solution there is 1202 grams? Yeah. In 1 liter of solution there is 1202 grams. Now in 100 grams of solution, there is 20 grams of solvent, of solute. Yeah. So in 1 gram it will be 0.2. So in 1202 grams of solution, we will have 1202 into 0.2 grams of solute. So that will be equal to how much? That will be equal to 240.2 grams, 0.4 grams. That means in 1 liter of solution, you have 240.4 grams of solute. Now, what is molarity? Molarity is number of moles per liter of solution. So number of moles will be how much? 240.4 divided by 166. So you can divide it and then check what it is. So that one calculation you will have to do. All calculations have to be done to 3 decimal places even for board. All calculations to be done to 3 decimal places. Even for your board, they have to be done up to 3 decimal places. Okay. Yeah, in chemistry portion confirmed as solutions. Okay, I will tell you, you ask him, I have no issues, he will let you know. This is not the time, please don't waste my time in all those things. You ask your other teacher, or you ask your coordinator will tell you. Please don't ask me what is the test syllabus and all, I don't decide it, okay? Yeah, so please ask your coordinator, they will guide you. Forget about it, let's not waste time on what is the test portion, let's focus on the job in hand. Yeah, so if this is understood, then here is the next question for you. Concentrated nitric acid is 68% is 68% nitric acid by mass in aqueous solution. Okay, what should be the molarity and molality if density is 1.504 grams per milliliter. Concentrated nitric acid is 68% nitric acid by mass in aqueous solution. What should be the molarity and molality if density is 1.504? Please talk about the subject. Anything about the subject, I will answer. This is the second question that we are working out. We will be doing one more question before we proceed. I hope all of us are able to understand. Concentrated nitric acid is 68% nitric acid by mass in aqueous solution. What should be the molarity and molality if density is 1.504 gram per ml? Yeah, molarity, and that's the solute. HNO3 is the solute, so we have to find it for that. You have to find it out, molarity and molality for HNO3. So I'll explain. So it is 68% nitric acid by mass. So if you take 100 grams, in that 100 grams, HNO3 is 68 grams, and water is the balance, 32 grams. Okay. So this is what it is. Now the question is, what is the molality and molarity? What is molality definition? Definition of molality is number of moles of species in 1000 grams of solvent. Okay. So in this, we'll assume, I understand that you will think that solvent is always the greater concentration. Yes. So it should be a solution of water in nitric acid. But yeah, look, they are explaining it this way because further when we go ahead, when we use the nitric acid, we're going to dilute it with water. So subsequently it will become water solution. So that's why we are just continuing with the terminology. Okay, so in 32 grams of water, I have 68 grams of HNO3. So in 32 grams of water, how many moles of HNO3? 16 into 3 is 48. 48 plus 1 is 47. 48 plus 1 is 49. 49 plus 14. 49 plus 14. 49 plus 14 is how much? Some 63. So molar mass of HNO3 is 63. So can I say that in 32 grams, you have 68 divided by 63 moles of HNO3? That means in 1 gram, you will have 68 by 63 into 32 moles. In 1000 grams, it will become into 1000. Yeah. So 4 will go 8 times, 4 will go 250 times. Then 2 will go 4 times, 2 will go 9 times. Then again, I need to simplify this. So if I simplify this, 4 will go here, 9.3630. 30 is 75. So 9.75 times. So the final answer will be 250. I don't like multiplication with 250. So I'll change it to 250 is equal to 1000 divided by 4. Okay, so I'll stick to that. That will be easy. So that just one division, the job will get done. So 6 into 4 into 3 is 12, 2 carry over 1, 24 plus 1, 25. So ultimately it will become 9750 divided by 252. 252. So that will give me the molarity. So 252 will almost go 40 times. So the answer is close to 40, not exactly 40, less than 40, but it will be close to maybe 39 times. Okay. So I hope we are able to understand how to calculate the molality. Molality is the number of moles of a species per 1000 grams of what we consider to be the solvent. Yeah, okay. Here is the question. It's a textbook question number 4 with some small change in it. Okay, so I hope you are able to understand. Now, the density is given to you 1.504 grams per ml. That means in 1000 liters, you have 1504 grams. Yeah, already in 100 grams, we have 68 grams of HNO3. So, in this much, we will have 1504 into 0.68 grams of HNO3. Yeah. Then what is molarity? Molarity is number of moles per 1000 ml of solution. So in 1000 ml of solution, you have so much divided by 63 moles of HNO3. So this will give me the molarity. So I need to calculate that. So if I calculate that, I get my answer. So we need to work this out a little bit. So let me just help you with the calculation there. So if I can work it out, it will be 1504 into 0.68. So when I do that, it will be some 1022 divided by 63. So it works out to be 16.23. Okay. So the molarity of the solution will be 16.23 molar. Yeah. So it is a 16.23 molar solution. One decimal wrong. It should be 16.23 molar. So it is 1.504 grams per milliliter. So if it is 1.50 grams per milliliter, 1000 milliliters will have 1504 grams. Okay. So in 1504, now 100 grams of solution has 68 grams of HNO3. So 1 gram of solution will have 0.68. So many grams will have into 0.68. So many grams of HNO3 divided by this will give you so many moles of HNO3. So many moles of HNO3 in 1 liter. So that is nothing but the molarity. Yeah, am I clear? Can we move on? To find out the molarity, I am given that the specific gravity or density is equal to 1.504 grams per ml. That means if I take 1000 ml or 1 liter of solution, in that 1 liter of solution, we have 1504 grams. Molarity. Molarity is number of moles per liter of solution. Number of moles per liter of solution. So I have 1000 ml in 1 liter of solution, right? So that is 1 liter of solution. I have so many grams. Now in 100 grams, the weight is 68%. So in 100 grams of solution, I have 68 grams. So in 1504 grams, I'll have 1504 into 0.68 grams of HNO3. Now this divided by 63 will give me the moles of HNO3. How did I get 63? HNO3 molar mass of HNO3. What is the molar mass? 1 plus 14 plus 16 into 3, 48. So 48, this is 62, 62 plus 1 is 63. So this is equal to 63. Okay, so that expressed in grams. So divided by 63. So now when you get this, this will give you the number of moles. So when you work it out, you will get what I calculated, 16.23. So you will get 16.23 molar. Okay, to find the molality, I already explained to you. This will give you the molality. No, where is the question? Yeah, here I found out the molality. Okay, how did I calculate the molality? In 100 grams of solution, I have 68 grams of HNO3. So in 1000 grams, I will have 680. How many moles is it? 680 divided by 63. So the answer is simply 680 divided by 63. So once 63, it will go 50 times here, 0.08, 8 into 3, yeah. So it is 10.8 molal. So it is 10.8 molal and then 16.3 molar. Okay, so if you can understand that, good. Let's do one last question and then we will move out. I'm looking for a specific question. Okay, so a solution of H2SO4 has a density of 1.15 grams per ml. If it is 1.5 molar solution, what is its molality? A solution of H2SO4 has a density of this much, 1.15 grams per ml. If it's a 1.5 molar solution, what is its molality? What is its molality? Okay, so if you can take a minute and then work it out, then I will solve it. So I'll explain. I'll start making sense of the information that we have. So first, 1000 ml weighs 1150 grams. Okay. Now, because it is so many molar, it also contains 1.5 into 98 grams of H2SO4. So, I mean, so you see this number is close to 150. This number is also close to 150. So our final answer will be very close to this value. So just to make sure that it doesn't, I can change the number. So I am changing it to 2.5 so that this will look like 2.5. Okay, just for that only I have done, no other reason. So this is 5 by 2. So 2 will make it 49. So 5 into 49 will become 2. Here 245 grams of H2SO4. That means in 1150 grams I have 245 grams of H2SO4. Yeah, this is grams of solution, but I need it for 1000 grams of the solvent, right? So 1150 is equal to, can I say it is equal to 955 grams. 955 grams of H2O. I have 245 grams of H2SO4. This 245 grams of H2SO4 is close to 2.5 moles. Is 2.5 moles. So in 995 grams of H2O, I have 2.5 moles. So in 1000 grams of H2O, I'll have 2.5 by 955 into 1000. So which will approximately be maybe 22.7. So it's a 2.7 molal solution of H2SO4. See, I'm saying suppose the solution is 2.5 molar solution and suppose its density is 1.15. That means in 1000 ml of solution you have 1150 grams. Okay. Now in 1150 grams you have 245 grams of H2SO4. This is of solution. This is of H2SO4. So if I subtract them, I'll get 955. So in 955 grams of H2O, I have 245 grams of H2SO4, which is nothing but 2.5 moles. So in 1 gram, I'll have 2.5 by 955. In 1000 grams into 1000. So this will be little more than 2.5, maybe some 2.7. Okay, is this understood now? So it is 2.7 molal. Why have 5 by 2? 2.5 is 5 by 2. Huh. 98 into 5 by 2. 245 is 98. 98 is the molar mass of H2SO4 into 5 by 2. So 2 will go 49 times. 49 into 5. 49 into 5. 50 into 5 is 250 minus 5. I got 245. Okay, guys, you have to be faster in calculations. When we consider 100 ml, how does it not affect the answer? What do you mean? When we consider 1000 ml, no, but we converted it into grams, no? So after that you have heated it. So after you have heated it, the molarity may change, no problem. So it doesn't affect the answer. Okay. So we want to know density. How is density, molarity, normality related? Okay. So can I say density into 1000 is grams of solution? Okay. Now molarity is number of moles of solute in density into 1000 grams of solution. Yeah. So density into 1000 minus molarity into molar mass. What will this give you? This will give you grams of solvent. Now, what is molality? Molality is equal to number of moles, that is molarity, divided by density into 1000 minus molarity into molar mass into 1000. So this will give you the answer. So the question is, how are molarity and density related? So this is how they are related. Molality is equal to molarity divided by density into 1000 minus molarity into molar mass whole into 1000. How did I get it? So density into 1000 gives you the grams, number of grams in the solution. Now molarity is equal to number of moles. So in density into 1000 grams. So molarity into molar mass will give you what? Will give you the weight of the solute. So from the weight of the solvent, I have removed the weight of the solute, so that I get the total. From the weight of the solution, I have removed the weight of the solute, so that I get the weight of solvent. So molality is equal to molarity divided by weight of solvent into 1000. So that is what it is. Okay. So I hope I am clear. So when we consider 1000 ml, okay. So yeah. So I hope this relationship is clear. These relationships cannot be memorized. These relationships are worked out by knowing the definition correctly. So the definition of molarity, all should be known correctly. So molality, moles of solute, SOLUT in 1000 grams of solvent. Molarity, moles of solute in 1 liter or 1000 ml of solution. Moles of solute in 1 liter or 1000 ml of solution. Okay. So this is important. If once this is understood, then we can work out whatever is required. Please think about it. Don't just take a pick and sit. Please work on it. I will wait. Okay. So if this is understood, then slowly let's move towards solutions. Okay. So this is how the strength of a solution is explained. I don't understand. What do you want me to explain? Okay, can you write this down? Write this question down. A solution of a solute having molar mass capital M is made in water. The solution has a molarity small m. If its density is rho, what is its molality? Okay, so 1000 ml of solution has a mass density into 1000. Okay, now it also contains small m moles or small m into capital M grams of solute. So mass of solvent is equal to density into 1000 minus mass of solute. Okay, so in so many grams of solvent we have m moles. So in 1000 grams of solvent we have m divided by density into 1000 minus small m into molar mass into 1000. So this gives you the molality. Okay, so don't worry, homework will come. Okay, homework will come. A lot of questions will come as homework. Okay, so we will sit and we will do at home. Yeah, so now if this is understood, let's slowly move towards solutions. Okay, I explained to you the other day solutions and solubility. I explained to you the other day that when a solute dissolves in a solvent, we call that a solution, right? strength of a solution. I have explained to you what is the strength of a solution. Next, I will explain to you what is the meaning of solubility. Solubility basically refers to the amount of the solute in the solvent. So usually there are different ways in which the solubility can be defined. We have learned all those things. We have learned, that is in terms of grams per cc, grams per ml. So many ways are there. Now, first thing is, why does a solute dissolve in a solvent? So I explained to you, we are not going to talk about all those cases where there is a reaction between the solute and the solvent. We are only going to talk about all those cases where there is no reaction. In such cases, mostly it follows the rule like dissolves like. So like dissolves like. And we are not going to talk about cases where there is a reaction. So we won't talk about solubility of HCl in water, nor will we talk about the solubility of HNO3 in water. Okay, we are going to talk about solubilities of other solutes which don't necessarily react. Say for example, we can talk about the solubility of O2, CO2, N2. Again, CO2, we don't want to talk much about it, but because it's a very weak acid and unstable acid, we can still manage, and we will talk about it. So we are talking about solubility of gases in solutions, in water. Okay, in water, we are interested in water because we want to know whether the fishes get adequate oxygen or not. What is it that they get? So we are interested in water. Then we are interested in solutions of solids in water. I mean, solids in liquids. And mostly the liquid that we are interested in is water. And we are interested in solutions of liquids in liquids. So here we can have different types of solutions. So we can have petrol in diesel. We can have any example here. This is what is predominantly used in industries. This is something that we work with it day-to-day life. When you take salt and you add it to water, you have a solution of a solid in a liquid. Yeah. So this is what happens in case of fishes, and in case of fishes, right? So we want to discuss all these things in a systematic manner. So first, I will take up solubility of gases in a liquid. So first, we will take up solubility of a gas in a liquid. Okay, so first we will work about that. So before we work, always we will try to think about, we'll try to understand that, look, there is a gas here. So let's say there is water here, and then let's say there is a gas here. Now, if this gas is dissolving in water, that means gas plus water should be more stable than gas separately and the liquid separately. Do you understand this? Basically, what I am trying to tell is, for any solution to form, there has to be a thermodynamic aspect, and heat must be released during the formation of a solution. Only if heat is released in the formation of a solution, it will be a spontaneous solution. So only then a gas will be soluble in water or in any liquid. Do we understand this? So do we understand that solubility of a gas in a liquid is spontaneous only if it's exothermic? That means delta H must be less than 0. Okay, and mostly they are exothermic. Sometimes, we want to get into free energy, and then we want to say delta G is equal to delta H minus T delta S, and even in that case, it will work out. Okay, do you guys know this equation, by the way? Delta G is equal to delta H minus T delta S. Previous slide. Ooh, here is the previous slide. This is the next slide. Delta G is equal to delta H minus T delta S. Solubility of a gas in a liquid is spontaneous only if it's exothermic. Mostly we are talking about delta H less than 0. But there are, okay. Huh? Do you understand this? So delta G is equal to delta H minus, yeah, Gibbs energy equation. Very good, very good, very good. Okay. Now I am asking you a question. Suppose on this side I have solute. In our case right now we are looking only at gas in liquid. Okay, we are not looking at anything else. So solute plus solvent gives the solution. Can you tell me if for this equation delta S is positive or delta S is negative? In other words, if I have S1 as the total entropy here, S2 as the total entropy here, can you please tell me if S1 greater than S2, S1 less than S2, if S1 is equal to S2, or nothing can be said? I am asking a question. Solute is there, solvent is there. Let the entropy on the left side be equal to S1. Let entropy on the right side be equal to S2. Tell me if S1 is greater than S2, S1 is less than S2, S1 is equal to S2. What is it? What happens when you make a solution? Does entropy decrease? Does entropy increase? Don't give me that formula, my dear friend. There is no difference between enthalpy and entropy. That is fine. Yeah. So is S1 greater than S2 or? So some people are saying entropy decreases. As of now, I have seen entropy decreases. Okay. Okay. Entropy decreases. Okay. Yeah. So that means. I have to again ask you, what do you mean by entropy? So let me dare and then let me say, ask somebody. Sundaram, can you please raise your hands? Yes, Sundaram, can you please raise your hands? Yeah, Sundaram. Anybody who wants to answer can raise their hands. I'm just asking you a simple question. What is entropy? Okay, so there. Can you can you speak? Tell me, what do you understand? Why do you feel entropy changes the way you said it is?
Sir, as the gas molecules dissolves in water, so that it will decrease itself.
Now, why will it decrease is my question.
The gas molecule attached to the solvent, sir. So the gas molecule cannot move it. So the entropy decreases.
So what? No. Entropy doesn't decrease because of that. Okay, fine. No issues. Good effort. Good effort. Okay. So now I will try to answer your question. So this is where I keep telling you students always that please think science is picturizable. Okay, if you are not able to picturize science, it means you have to read more and you have to try to understand more. Okay, see, entropy is a measure of randomness. Okay. So suppose here I have a gas, let's me say O2. So if I put my hand into it, what will I be touching? Will I be touching O2 or will I be touching something else? You can say 100% I'll be touching O2. Yeah. Now suppose here I have another thing, let's say H2O or let's say nitrogen. So if I put my hand here again, I can tell you with certainty that if I had water, I'll touch water. If I had N2, I'll be touching N2. Now, the moment you mix it here, you have O2 and you have N2 and you put your hand here and you are touching only one particle. Which one are you touching? Are you touching N2 or are you touching O2? So do you understand? So where is the randomness more? Is there any randomness here? No. Is there any randomness here? No. There is randomness here. So where is the randomness more? Randomness is always more where in solution. Why is the randomness more in solution? Because you have multiple types of particles. So when you say random, it means in that context. So we need to understand what is the meaning of this randomness. The randomness is with how much surety can you say that yes, you are touching whatever you say you are touching. So in this case, I am touching oxygen, nothing else. In this case, I am touching nitrogen, nothing else. In this case, I am touching I don't know what. So randomness here is more. So S2 will always be more than S1. Okay, a solution will always have a greater randomness than solute and solvent. Okay, I hope you are able to understand. Now, when you say delta G is equal to delta H minus T delta S, I made a loose statement saying that look, delta H should be less than 0. But are you able to foresee a situation where delta H is positive, but still magnitude wise it is less than T delta S? So this makes it overall negative and it is still spontaneous. Do you understand this? Yes, are we able to understand this? I made a loose statement saying that look, delta H should be less than 0. But I am now telling no. Spontaneity comes only from delta G. And delta G is equal to delta H minus T delta S. Delta S, howsoever small, is still positive. So to that extent, T delta S, if T delta S is more than delta H, which is endothermic, even then it will be spontaneous. Do you understand? Yeah. So entropy refers to the measure of the level of disorder. Yes. So if you have a pure solvent, the disorderness is not there or it is released. Okay. Enthalpy, forget about it. I'm not talking about enthalpy. So when gas dissolves in water, the volume increases. Oh, forget about all that. No. What volume doesn't increase? We don't know all those things. So the molecules, no. I gave you the answer now. Okay. So there is an increase in randomness. No increase in randomness because of that. Randomness refers to the surety with which you can say what you are saying. So if I have pure solvent, I can tell you with surety that I am touching water. Now if I have a solution, I can't tell you with surety which one I am doing. So the randomness here is more than the randomness there. Okay. Now gases are going into the intermolecular spaces, so we won't know much about the change in volume and all those things. Yeah, am I clear? Can we all put some yes, no, maybe? Sir is del. What is this del? So you mean you are clear or you are not clear? Yes, Levin. Clear. Okay, good. So Let us understand that. Okay, that's not very important for us but I made a loose statement, so I should be careful. Okay, so now let us look at the factors influencing solubility. Okay, factors which influence solubility. We are talking about a gas in a liquid. Okay, so we are talking only about a gas in a liquid. We are not talking about anything else. So first is the effect of pressure. Okay, so the statement I am going to make is this: if the pressure of the gas above the liquid is high, solubility is high. If the pressure of the gas above the liquid is high, solubility is high. Okay, there are multiple ways in which I can explain it. So this is the liquid, these are the molecules, gas molecules here. So now suppose you increase the pressure, so now you have gas plus liquid gives you solution. Okay, suppose pressure is high, then the molecules are kind of forced to go into the liquid. The force is high to go into the liquid, so solubility will go up. Yeah, you don't like it, no problem, you increase the pressure here. When you increase the pressure, look what happens when when the gas dissolves in water. There is a constant change or interchange between the gas molecules in the water. That means there is exchange. That means there is equilibrium here. If the gas enters the liquid, pressure decreases. If the gas comes out of the liquid, pressure increases. So now if you increase pressure, Le Chatelier's principle tells me that a system will move to the right. So when you increase the pressure, what will happen is the system will move to the right. That is, more gas will get into the liquid, thereby trying to reduce the gas pressure. So whenever you increase the pressure of the gas above the liquid, the solubility of the gas in the liquid increases. No problem, no problem. Yes, Senthil, we will go not 10 minutes. I will give you 20 minutes break. Just give me few minutes. I will give you 20 minutes break. Sundaram, one simple philosophy I have in life: whatever you can understand, understand. What you can't understand, memorize. Okay, because everything cannot be understood by everyone at the same time. It is an impossible activity. Yeah, so I am now trying to explain to you. Try to understand, then we will see. I am saying that if this is a liquid, if this is a solute, then the solute particles getting into the intermolecular spaces of the liquid is basically what solution is. Okay, so solution is this. Now if you increase the pressure of the gas of the gas about on whose solubility you are talking above the liquid, then because the pressure is high, that means what, it will be forcing itself on this with a higher force. So more amount of this gas will go in. So that is one lame way of understanding it. There is yet another way of understanding it. You have solute becoming solution. Here pressure is high, here pressure is low. Okay, why pressure is low? Because gas has moved in, so less gas now. So according to Le Chatelier's principle, if a system is in equilibrium, yeah, if you disturb a system in equilibrium, then what happens? Then the system moves so as to nullify the effect. So earlier everything was in equilibrium. Now you have increased the pressure of the gas by increasing the number of gas particles. So the system will move to decrease the number of gas particles. How will the number of gas particles decrease in a closed system? By more gas dissolving in the liquid. Okay, by more gas dissolving in the liquid. So as you increase the pressure of a gas, its solubility increases. Okay, worst case, you can say experimentally observed. Experimentally observed. This is the foundation for what we will call as Henry's law. I will give you a 20 minutes break. Now it is 2:17. So I will start my class only at 2:37 by my watch. Okay. So please go back. We will come and we will continue to read what we are reading. We have to do Henry's law today. Only then we will move on. Okay. So please take a break and come back. So pressure is one of the factors which affect solubility. Temperature is another one. We will. Is it safe to drink methanol mixed with ethanol? Hey, it is deadly poisonous. Okay. Deadly poisonous. Deadly poisonous. Yeah. Deadly poisonous. So please don't think about it. Don't ask that question. Yeah. Okay. So let's take a break. What about physics class? Tomorrow we will make up for the physics class. No, there is no physics class. Tomorrow we will do. Already you guys have asked me so many questions. I have not answered them. So let me answer your questions, then we will do. Okay. Yeah. So please take a 20 minutes break. Don't waste your time here. Come back quickly.
Hello, sir.